Hello everyone, I'm Charis, your physics teacher in Senior 6. I want to help you to understand very well properties of sound waves. Previously, we talked about characteristics of sound waves, but here we are going to learn properties of sound waves. Nothing else apart from understanding other properties of waves. Remember, previously you learned that all waves, they have some basic properties. The same to sound waves, we have refraction, we have refraction, and we have diffraction, but also interference. But you may ask yourself, why are you going to start by diffraction? The reason is refraction and refraction, there is a link. But also diffraction has a link with refraction, but also interference has a link with diffraction. Very interesting. Let's start by reflection. Let us take an example. This is an obstacle. Let's call an obstacle. Okay? And we have a wave. But don't you think that it is grateful that the voice that I'm using, this is sound waves. Let us take, this is my voice. Now, the wave is moving in this direction, okay? After striking to the wall or the obstacle, it would reflect back. Okay, so this one was moving in this direction, but this one, which is coming back, is moving in this direction. So how can we explain reflection? Reflection of sound wave that is coming back of initial wave when it meets an obstacle. So that is what you call reflection. Let me use another example of this reflection. Let us say this is an obstacle, okay? And let us imagine a line, we call it normal line. If you have a wave which is coming, okay, it is going to reflect back. This process of bouncing back of a sound wave after meeting an obstacle, that's what we call reflection. Okay, that is refraction. Now let us talk about refraction. Did you understand very well reflection? Good and well. Now let's talk about refraction. Refraction, that's the bending of a sound wave after reaching to a medium where it can pass through. And that phenomena, it is called refraction. Let us suppose this is a medium. Okay? And there is a question that I want to ask you, or ask your friends. When you are having reflection, can we have reflection without obstacle? The answer is no, because by definition, it is bouncing back after meeting the obstacle. Then let us think if you have a medium like this, and suppose that this is a wave. Remember, we are dealing with sound waves. We have an imaginary line, we call it normal line. instead of going back, it bends from, this is the first medium, medium 1, this is medium 2. After bending, don't you see the angle between the normal line and this wave and the normal line with this wave? They are different because this one is big, this one is small. So the bending of a sound wave after meeting a medium passing through, that's what you call refraction. Now, let me help you to understand what is diffraction. Diffraction if I have a medium but here I have a hole, okay, I have point P, let's suppose point P, where we are having sound or production of sound waves. The waves, they are coming here through that hole, but after reaching to this hole, it is going to be spreaded. After being spreaded, because as the passing through here, don't you see that is a small hole? As the passing through here, when it's reaching this is first medium, this is the second medium. As it passes through here, now it spreads out. That phenomena, that's what we call diffraction. Diffraction. So far we understood what is reflection of sound waves, what is refraction of sound waves, and what is diffraction of sound waves. Now, you have an interest of understanding. If I understand at least there's a 3, what if I can understand the 4th one? Very wonderful. This is the interference. This is what interference. And let's give an example. If you are talking with someone and someone cuts you in what you are saying, don't you say that you have interference? Let us link with that example to understand very well what is interference. Interference of sound waves. Let us think if you have a medium like this and a medium like this. So this is an obstacle, but here there is a hole, here there is a hole, okay? So here there is a screen. That is a screen. Okay? Now, if you have the source here, source of sound wave. Now, as it enters here, there is a point that this one will come and meet here. But also there is a point that the sound which enters from this second hole, and we call it slight. Let's call slight number 1 and call slight number 2. Okay? The source which is coming from slight number 2, if they meet here, let's call this point P. The fact two sources of sound waves meet at one point after passing through these two slides at this point, this phenomena, this is what you call interference. Now, you may ask, if the interference, what does it mean? It means at this point, you cannot distinct the source of this sound and the source of this sound. So it is a mixture. As long as they are mixed, now, don't you see that you are not able to detect the original sound to mean that's what you call interference. Now, if I have a distance here, let's call distance between these two slides D. And I have the distance from the screen and from the source 1 and source 2. Then let's call capital D. Then if you have the distance from the center, let's say this is the center. Now let's call this X. The distance from point P at 2.0. This is the distance X. Now, later I'm going to show you how the interference can be detected and how the separation between the points O and points P can be calculated. But there is something which is very interesting. Where there is interference points in light waves, we call it bright fringe. But in sound waves, we don't use this term bright fringe, we just call it interference point. So don't be confused by bright fringe and the interference points, because bright fringe is used for light waves, not sound waves. So far we have discussed about properties of sound waves. Remember, we started by reflection, refraction, diffraction, and interference. So with that, with these 4 properties, and link them with characteristics, now you are able to understand the overview of sound waves. Next time we are going to enter in calculations and to know where sound waves are propagated, because sound waves need the medium. They are different from electromagnetic waves where we don't need a medium. If you need more information, don't hesitate to ask me any question as your instructor, but also you can check on YouTube channel, that is Ikaramu TV, and like it. Then we'll subscribe on that YouTube channel, but also we have a website where you are going to learn more about sound waves, but also other units of Senior 6, you are going to find them on www.umenyi.net. Please like our YouTube channel, ikaramu.tv. Thank you very much. See you next.